Okay, we're going to solve this quadratic. Now, everything's already moved to one side, so we're good there. And what we're going to do is we're going to see if we can factor this. Now, it turns out if you try to factor this, you can go ahead and write down the list of numbers of the possible things that multiply together to give you 65, but are going to add to give you 16. I don't think you're going to find ones that work. So what we're going to do instead, we got two options. We could complete the square, or we could use the quadratic formula. Either one should work. So I'm going to go ahead and I'm going to complete the square. The reason I'm completing the square is because I think most students find the quadratic formula easier to work with, and completing the square they need a little bit more practice at. So, but your answers will be the same either way you do it. Now, don't be intimidated by the u in there. It's just like an x. It means the same thing. It's just our variable. So what I'm going to do is I'm going to take the 16. I'm going to divide it by 2, and then I'm going to square that. So 16 divided by 2 is 8. 8 squared is 64. That's conveniently nice to this. Now, one of the things that you could do is you could add or subtract 64, or you could be a little bit more creative, and you could take the 65 and split it into 1 plus 64, and that actually gets you your 64 right away. So we've got u squared plus 16u plus 64 plus 1 is equal to 0. Again, if you want to add the 64 and then subtract the 64, you end up right here again. Okay, so this gives me u plus 8 times u plus 8. That's this piece right here. And that's going to be equal to, I'll move the 1 over, that'll be equal to negative 1. So that'll give me u plus 8 squared is equal to negative 1. I already have an issue here. Okay, so on this particular problem, I have something squared equal to a negative number. Now, it does not say in the directions for this problem that we're going to use complex numbers. So it usually should state, are you using just real numbers, or are you using all of the complex numbers? Because real numbers are a subset. If we were working with just real numbers, there would be, so if we were told we are just working in the reals, if that was the case, then we would say that there is no real solution. And we'd be done here, because you can't take a square and have it equal to negative 1 with just the real numbers. However, I'm assuming that the person who wrote this wants to use complex solutions, so including imaginary numbers. If that's the case, we've got to go a little bit further. So let's assume imaginary solutions and solve this. So I'm going to go ahead and take the square root of both sides. Remember, when you're the one that puts the square root in there, you got to do plus or minus. So square root of both sides will give me u plus 8 equals plus or minus the square root of negative 1. Okay. Well, we know the square root of negative 1 is just 1i. So we could write this down as 1i. Or if you want, just I is fine as well. Okay, in fact, I'll rewrite it like that so it's a little bit smoother. And then I have my u plus 8 still over here. Okay, two separate equations here. One is u plus 8 is equal to positive I, and the other one is u plus 8 is equal to negative I. So I'm going to subtract 8 from both sides. So u is equal to negative 8 plus I, or u is equal to negative 8 minus I. Now, when you have an imaginary solution, or what we call, this is complex, this is a complex number, because it has a real part and an imaginary part. These guys, when you're solving quadratics or other higher order polynomials, they come in pairs, and they come in pairs specifically so that you end up with what we call a complex conjugate. And so that is the case where the numbers are all the same, except the difference is only the sign in between the real part and the imaginary part. So what are your solutions? Well, we've got two of them in the complex plane. We've got one as negative 8 minus I. That's one of the numbers. And the other one is negative 8 plus I, just like that. So again, We're assuming in this problem that we're working with complex solutions. If that's the case, then these are the two answers. So both of these complex numbers do work in this equation. If you went ahead and plugged them in, did all the FOILing out, it would work. If you're working with just the real numbers, there would be no solution for this because there's no real numbers that solve this above quadratic. Okay, so hopefully that makes sense for that problem.